Thanks for joining me today. My name is Nevin, and I'm a developer relations engineer at Google, supporting our Android media features and APIs. I'm excited to talk to you all today about the relatively new transformer module in our Jetpack Media3 library. So we'll start with a quick overview of Media3, just to make sure we're all on the same starting page. Then we'll dive specifically into the APIs offered by Transformer and run through a bunch of examples of how you can use them. And lastly, I'll describe how you could incrementally start including Transformer in your app so that you don't need to undertake a whole migration project all at one time. So what is the Jetpack Media3 library? Jetpack Media3 is your one-stop shop for APIs about media playback and editing use cases on Android. Version 1.0 of Media3 released early last year, and we're already seeing that it's being used in more than 30% of the top 1,000 apps on the Play Store. I imagine many of you are already familiar with Exoplayer for playback, which is now a part of Media3 as opposed to being a standalone library. Speaking of which, if you haven't yet, please do check out our docs on migrating to Media3, since updates to Exoplayer will only come to Media3 going forward. Today, however, I'd like to focus on the Transformer module, which includes APIs specifically for media editing. Social media and video are becoming increasingly important, but we've heard from app developers that building media editing features on Android has been historically difficult, especially when it comes to ensuring good performance and reliability across the huge variety of devices that are in the market. So to address this, we're investing in support libraries that offer improved quality and new capabilities for media editing so that you can build cool experiences for your users. We're focused on three main goals when it comes to Transformer. First, editing should be easy. We want to enable you to be more efficient as you write and maintain your code so that you can save both time and money. We handle the complexity of the lower level APIs so that it's easier for you to write and maintain your code. Transformer is also built with performance and quality in mind, including device-specific optimizations. Our code is thoroughly measured and optimized for high throughput. And of course, we also expect Transformer to be reliable. Transformer supports API level 21 and onwards, so you can reach 99+% of devices in the market. We also test on a wide range of these devices to catch chipset-specific bugs or framework issues and implement workarounds for them so that you don't have to worry about them. Media3 supports a range of content creation use cases with full interoperability between Transformer and Exoplayer. Our ethos also includes easy customizability. So among other capabilities, you can create custom audio and video effects. You can control codec configuration and fallback behavior. You can set a custom muxer for writing your media containers. And we're also continuously working on expanding our APIs so that you can build fully fledged compositions. OK, that's enough preamble. Let's dive into some actual examples of how to use Transformer. Starting off simple, we'll take a look at how to transcode video files from one format to another. First, we'll create a Transformer instance. Generally speaking, this will be your entry point into most operations with Transformer. This is also where we can set the desired output MIME types. And we can attach a listener to the Transformer object that will be notified for completion or error cases. Finally, we simply start the transformation by supplying it an edited media item as the input and a path for the output file. Transformer also includes a host of video effects that you can use directly out of the box. For this example, let's define a video effect that will flip the video horizontally and also rotate it 180 degrees. The effects item then collects a list of all the audio processors and video effects that you want to apply. Of course, for this example, we don't have any audio processors, but we have included the video effect that we just defined. Finally, we configure an edited media item using our input media item and the effects that we want to apply to it. And here's what we end up with. Cool. But what if you want to do something fancier than what the inbuilt effects allow for? Here, we're creating a custom effect by subclassing the inbuilt matrix transformation to zoom in for the first second of playback. The rest of the code stays exactly the same, and we get the output that you see here. I'll just go back and play it again real quick. Nice. For advanced custom effects, you can implement a custom base GL shader program. The key method to take note of here is draw frame, because this is where you can process each individual input frame. We actually use this to define some of the effects in Transformer as well, so you can check out the source code for overlay shader program or color LUT shader program in the Media3 GitHub repository to see some examples of how you can use this draw frame method. And if you're looking to do something even more advanced, you can implement a custom GL shader program. The key method to take note of here is QInputFrame. GL shader program is different in that it allows you to create custom effects that are combining multiple inputs. Then you'll define a video effect with the GL effect that uses your custom shader program. And the example that you can see on the slide here is from our Transformer demo app. And it's using a media pipe frame processor for face detection in conjunction with some of the other built-in effects, such as trimming. All right, so far we've only been dealing with a single media item, but for the next set of examples, let's take a look at how you can combine several into one final product. The pattern we've used so far is to create an edited media item built from the input media item, as well as the effects that you want to apply to it. To create a composition, first we'll take these edited media items and group them into edited media item sequences. From there, you can create a composition out of one or two of these edited media item sequences. The current version is restricted to having one sequence that can have video and image items, plus one sequence that contains a background audio track alongside it. Future updates to Transformer will enable compositions to have more than two sequences with arbitrary media items. And here it all is in code. So I've started by defining 3 edited media items, a video and an image that will join together so that the image plays right after the video, and an audio item that we'll use for the background track. As described before, first we create sequences with our input edited media items, and then we add the sequences to a composition. I've also set the sequence with the background audio to loop so that it lasts the full duration of the main sequence. In addition to applying effects directly to edited media items and sequences, you can also apply the inbuilt presentation effect on entire compositions. Presentation effects control how a frame is presented, such as setting the output resolution or changing how the input pixels map to the output frame geometry. As an example of operations that can be applied to entire compositions, however, let's take a look at how Transformer can also help you deal with special formats. With more and more devices supporting HDR video capture by default, you might need a way to tone map HDR content down to an SDR color space. Here you can see that we set the HDR mode for the composition to tone map from HDR to SDR using OpenGL. This, as mentioned before, is also where you could call set effects to apply a presentation effect to the entire composition. The editing libraries in Media3 provide HDR support to ensure that apps and partners can seamlessly integrate with the HDR content. And on API levels 33 and up, Transformer's default behavior is to retain HDR data when possible, but fall back to OpenGL tone mapping when not. If you need to allow HDR videos to be displayed and edited in SDR across a wider range of Android devices that may not have hardware HDR support, you can tone map HDR content down to SDR. For input media files in an HDR format, you can tone map to SDR either by using tone mapping with OpenGL, which is what we saw in the previous example. This is supported on API levels 29 and above, and if OpenGL tone mapping is not supported, then Transformer will throw an export exception. Alternatively, you can also use the framework media codec for the tone mapping, and this operation is supported from API level 31 and above. And finally, we're adding support for Ultra HDR images in the Media3 1.4 release that's coming up soon. Okay, and then as I mentioned before, Exoplayer and Transformer are engineered to work hand in hand. So next, I'll show you how you can use Exoplayer to preview the effects that you're planning to apply with Transformer. The code you see here demonstrates kind of a basic initialization of an Exoplayer instance, except that we're also calling set video effects. And we're supplying it with the same effect that we would have applied to an edited media item or a composition. Note that there are some limitations to this. For example, it doesn't work with DRM protected content, and set video effects needs to be called before you call prepare. For more examples, including showcases of developers who are already using Transformer in their app and seeing significant improvements in performance and reliability, I highly recommend checking out our talk from Google I/O this year. Okay, and then for the last big topic I'll cover today, I'd like to introduce the idea of using Transformer solely for the encoding and exporting part of the media processing pipeline. This way, you could incrementally try adopting new Transformer capabilities and gradually take advantage of the benefits of Media3, rather than, like I said, having to undertake a huge migration project all at the same time. An export operation consists of 3 stages: loading the media, modifying it as desired, and then outputting the result. Transformer uses the concept of an asset loader to handle the loading media step. This is responsible for fetching the media, whether it's local or remote, and decoding it if needed. By default, Transformer uses Exoplayer for this, so you get the benefit of its support for a wide range of formats, or you can write a custom asset loader. More on that later. For applying effects, the media flows into separate pipelines for audio and video processing. As you saw in some of the previous examples, we pass in separate lists of video effects and audio processors. These get applied to the media in the order that they're given. And finally, a muxer takes the encoded audio and video samples and writes them to produce MP4 files. Currently, Transformer uses the framework media muxer, but we're also working on an alternative muxer implementation as part of Transformer, kind of similar to how Exoplayer has bundled extractors for reading media files. The video pipeline expects to receive video decoder output either via a surface texture, bitmap, or OpenGL texture, and passes input frames into the video effects as OpenGL textures. The audio pipeline expects byte buffers that contain PCM audio samples, and these are provided to the audio processors. Now, I've really only scratched the surface in terms of how exactly Exoplayer handles exports, Transformer handles exports, rather. But what that means is if your app already has video rendering code in OpenGL, you can plug your existing media pipeline into Transformer's pipeline and benefit from Media3's functionality for encoding, muxing, and applying any additional effects that you might want. The class that handles this is called the Texture Asset Loader. And if this use case sounds interesting to you or something you might be looking to investigate further, please do reach out to us so we can collaborate on your implementation. We'd love to hear from you, whether you're interested in media editing with Transformer or other media-related topics. So please feel free to reach out to me. And you can also find us at office hours upstairs all throughout the day. I also recommend checking out our GitHub repositories for our sample apps. We have the Platform Samples app on the left and Socialite on the right. Socialite in particular might be interesting since it demonstrates Transformer in action in the context of a social media app. That was a lot to cover, but hopefully this talk was inspiring. I'm looking forward to seeing the delightful Android media experiences that you all create. And thanks for your time. Hope you enjoyed the rest of DroidCon.